Okay, good evening, everybody, and welcome to the introduction to Geology virtual open evening. I'll be presenting. My name is Dr. Kevin Jones, who runs the Geology department as part of the Geography and Geology department. Head of Geography will be helping me this evening. That is Miss Strong. She's going to be dealing with organising questions that you may have about the presentation and anything to do with the course. At the end of the session, there will also be two of my upper six students, Sophia and William. We're going to tell you about their experiences, and they will be answering some questions about how they thought geology went this year, and fieldwork and other aspects that they'll be looking at. So, what is geology all about? So, geology is attempting to understand the evolution of our planet. Now, planet Earth was a molten ball of magma about 5.6 billion years ago, and it's evolved in that time frame. And luckily for us, um, the majority of that history has been recorded in the rocks. So, what we as geologists attempt to do is look at the rocks and see what record of the evolution of the planet and attempt to find out how the planet actually works by looking at various aspects in geology. Now, we can look at the tectonic history of the planet. We can look at how fossils have helped us gauge the evolution of life and how they've helped us to gauge things like the major mass extinctions, for instance. So, where we look at sort of problems like, well, was it really an asteroid that killed the dinosaurs? We can also look at other things like the record of the processes in the past and whether they are the same as they are now. We can look at a river and try and find deposits in the past that were formed in river environments, or look at deep oceans and attempt to work out what's going on today. Now, of course, a lot of this is it's a relatively the science aspect of it is relatively modern, but the rocks have been there for billions of years, but we just look at them in a different way. As geologists, as you can see from the photograph on the left there, um, we go out on field work as well, and that's one of the main aspects I'll be talking about as we go through this short presentation. The course outline is shown to you on the next slide, where the course is divided up into three major units, and I'll just explain the assessment later on. Unit 1 is what's called the fundamentals of geology. That's the one on the left there, the blue one. When you come into geology, because very few students have actually learned anything or heard anything about the subject before, they may have done a little bit of geology at lower level, mostly in physics or a little bit of plate tectonics in geography. We start the course assuming basically that you have a fundamental understanding, but we build on all those very basic principles. So we're basically starting from scratch. So we're going to start off with elements, minerals, and rocks. And then we slowly go on to looking at the processes on the Earth's surface. And that includes internal and external processes. So we look at rivers and glaciers, we look at deep oceans. We look at the main types of rock. We look at the igneous rocks. We look at particularly volcanoes, which is a rather exciting part of the study that we look at, sedimentary rocks and metamorphic rocks. And we get plenty of hands-on looking at samples in the laboratory and in the field to try and understand how these rocks have formed. But I suppose more importantly, what they tell us about the past processes on the planet. And in particular, when we go on field work, we try and elucidate the history of areas by looking at the different rock types. Now, time and change, which is one of the bigger modules in that year, is all about the fossil record. What can the fossils tell us about the evolution of the planet? It's a very popular option. A lot of students go on from here to study paleontology at other universities as well. So we look at all the things like the ammonites, and we do look at dinosaurs and trilobites and other animals, trying to work out how they lived from the fossils themselves, but interpreting how time and the climate on the planet has changed, and understanding major catastrophic events like these mass extinctions. Now, the topic most students will be familiar with is Earth structure and global tectonics, but in this sense, we'll be looking at it in a much more detailed approach by looking at how we can actually access information about the core of the Earth and how the Earth actually works deep down in the mantle and other parts of the planet, as well as looking at the classic studies of continental drift and the work of Wenger and other people like that, and understanding how the plates moved around the planet, what speed they move, and looking at why we get earthquakes and major volcanic areas related to those. So the fundamentals of geology is really the background module that we start off with the course. As we go into the end of year 1 and into year 2, we get into interpreting the geological record. Now, this is more a sort of interpretation element of the course rather than understanding and learning the fundamentals. So we start to use the skills we've developed in year 1, looking at rock forming processes in more detail, looking at rock deformation, and that involves how rocks are squashed and deformed and they fold and fracture. And then more on past life and climates. We sort of take a David Attenborough type approach to things, look at videos and other features of how we can interpret the geological record. Then we look at the Earth materials. Now, this module is what the students are doing at the present time. We're looking at the formation of the Earth's major mineral resources, and that includes oil and gas and water. And at the moment, we're looking at metallic deposits. Some of the students may tell you a little about that in a moment. So we sort of look at those resources in it's sort of an engineering and jobs related sort of geology, but we'll talk more about what we can do with geology later. Now, in year 1, students have to go through what's called the CPAC practical endorsement of coursework, which I'll talk a little bit more about later, where we have to do 20 assessed practicals. And that includes, of course, field work as well. And I'll speak on that in a second. Now, in year 2, we go into what's called the geological themes option. The first one of those is what's called geohazards, which is looking at earthquakes and mass movements in particular. And we look at the major earthquakes in the past, such as Japan in 2012 and Haiti. But the mechanics behind it, why did you get an earthquake? Why was it such a large scale? Why was it so devastating? We're sort of taking more of a problem solving approach to this. Now, the T2 option, really the way a geologist speaks to another geologist or talks their language is by understanding geological maps. And throughout the first year, map work is looking at sort of problem solving approaches to understanding geological maps, and also to looking at real geological maps such as the Geological Survey publish. So understanding maps and using maps is a major part of that, and actually does form a lot of the assessment of the whole course. You then get the option to do one of the special topics. At the moment, we have chosen to do geology of the lithosphere, which is simply understanding igneous and metamorphic processes in relation really to major mountain ranges such as the Himalayas, the Pyrenees, the Andes, how they've evolved and what they tell us about how the planet's evolved over time. So it's quite a complex module, but it puts everything together they've learned throughout the years into an integrated approach to that final part of the course. During the course, everybody will learn a series of what we call transferable skills. Geology is a very practical subject. Most of the courses, we have practical elements in every lesson, and that could involve either complex calculations or even very simple calculations to understand simple features. We develop some writing skills, although we don't have the sort of essay style questions that many of the other social sciences have. Mostly they are short answer style questions, but I can answer any questions on those later if you have any. But we are developing a scientific approach of observation, recording and interpretation of our observations to solve geological problems. And the brain caption there is it's a problem solving approach that we use. And I may, for instance, give students simply a mystery box of rocks, one lesson, and say, well, how do they link together? What can they tell us about each other? How do they link to a map? So it's that kind of approach which gets the students thinking and problem solving. But we also do lots of research as well, looking down a microscope, which the students are about to come on to in the second year at some point, and researching using other resources such as the internet, etc. Fieldwork, as I've said already, is a major element of the course, and I will talk about those in a second. There's a lovely picture of the students in the Lake District last year on the left. And I'd already spoken about the map work. This is what is called a simple problem map here. It's a setup map, but is used to train the geologist in the skills of interpreting geology from a map. So really, we focus very much on practical skills throughout the lessons and these transferable skills, which are very useful for other subjects and going on to degree level. Now, of course, fieldwork is a major element of geology, and we have two residential courses, which hopefully will run again next year. The second year course is the one you can see on the screen at the moment. This is looking at the geology and structure and processes in Dorset, yes, the Jurassic coast. Very large ammonite there on the top right-hand side, and some belemnites on the bottom left, fossil squid. The fieldwork basically gets the students to produce their own geological map of Lulworth Cove in that area and work out the processes and the history of the rocks within that sequence, looking at them in detail through various sections, understanding what the fossils tell us and how they've been deposited tells us more about the processes which went on during the deposition and evolution of the rocks, and also understanding why we get this lovely fold-like structure called the Lulworth Crumple there in the foreground on the large picture with Lulworth Cove behind, and how this all goes together. So it's a holistic approach to understanding how we get the rocks of an area like Lulworth Cove. The photograph on the bottom right is simply showing us which was in fact a very famous location called the fossil forest. So at some point in the past history, there was in fact a fossil forest about 190 million years ago in that area. And we can look at the evidence for fossil trees and other things in the Dorset region. So this really is a fantastic opportunity to go and study the rocks in the field and generate ideas about how they may have formed over time. The first year option takes us off up to the Lake District, where we can look at rocks which are recording sort of deeper levels in the earth and understand some of the processes that go on over time. The rocks here are a lot older and a bit more complex, but it is a classic area of geology, in particular to study granites like the picture there in the middle at Shap, and its effects on the rocks surrounding it, like the picture on the right. There's beautiful crystals radiating outwards from the rock there, and there's just in the middle at the bottom there a photomicrograph or a thin section of one showing you a similar crystal. So the Lake District is, we go to a place in the Lake District and we stay in a residential site, a field centre, and that part of the course is taught by external professionals who are very understanding of the geology of that region and are experts in understanding the processes. So it's a bit of a break for me, but the students get a really good understanding of the geology of that area. On both field trips, students get the chance to tick boxes for their qualifications and assessment throughout the 2 years that they are on the course. How do we support our students? Throughout the year, we have a carefully sequenced curriculum through those 3 components I showed you earlier on, what we call C1, C2, and C3. Each of the options has a study pack to go with it, which students can actually use, and virtually all the PowerPoints and all the resource materials are kept on what's called our SharePoint system, where students can access them throughout the year. So if they are ill or they couldn't make a lesson for some reason or another, they can catch up by going through all the PowerPoint and all the materials that are on our SharePoint site. Now, we do, in fact, focus very much in geology because it is a practical science. We focus on the practical skills. And each lesson, as I said, will be practically based. It could be fossils, it could be rocks, it could be maps, it could be looking at some structures. We could have a video, such as a David Attenborough video, to show something about evolution. So we very much have practical and problem-solving skills. That's really the last point on the slide there. We often use an investigative approach to this problem solving. Each lesson will have some kind of assessment at the end or during it to assess how the students are getting on during the lesson. And of course, we have tests every now and again just to check that the learning is working. Now, outside of the class, we do have support sessions. We tend to have an open door policy here where students can just come and find us and ask questions whenever we're available or book a time slot throughout the year. Now, these have been online at the moment, but for various reasons. One-to-one meetings are scheduled, and of course, we can get assistance in any lab or practical work they intend to do. So that really sums up how we support our students. Now, I've mentioned a little bit about the assessment, just to clear a few points up here. The assessment is carried out through the 2 years, but as I said, the main CPAC, or the practical endorsement, is what needs to be, it's a pass or fail situation like it is with most of the sciences. 20 specified practicals throughout the year, not all of them assessed, but we do need to do all of them. And 5 components are actually assessed, such as following instructions, working safely, taking an investigative approach, recording an observation, and research. And these things are marked through the year as we go on. And most of that work is finished by the first year, but if we need to improve our skills for some students, we continue that during the fieldwork and part of the second year. Now, geology tends to be a relatively small group, but we do join the geographers as an integrated department. Some geographical society talks are clearly related to geology. We have a couple of volcanologists who come in every year to talk to us. And some of our students from before from who've gone through this system come back and have a chat to students about various topics they're actually doing at uni or actually researching further down the field. We do have compulsory 4 days fieldwork and some optional fieldwork. 4 days, we tend to extend that a bit because it is a physically fieldwork based subject. So we tend to have 2 residential fieldwork trips, one in the first year, one in the second. I've just mentioned those. And finally, yes, we do get talks come from students. We have a student from last year coming in to talk about planetary geology. She left here 4 years ago and is now doing a PhD in planetary geology up at Manchester University. And we've also got students from Oxford and Cambridge and other departments who come back and have a chat to say how they've used their geology A level to get on and do a degree in geology further up the line. Now, we have very good performance in geology. It's a small group, so we get very good hands one-to-one on help, particularly high grades, well above the average here. And yes, virtually everybody passes. So we're looking at very good performance throughout the 2 years that the students are here. And a lot of our students go on to do geology afterwards. And what can you do with it? Well, geology is can be taken as a science. If you're looking for a third science and you don't want to do physics or chemistry, then we'll come and do geology. It's there to count as a third science to get you into a university. Or if you want to do geology, do it with any of the other 2 sciences, maths, or you can take a link with geography or social sciences and go down the environmental sciences route if you want to. Geology clearly supports geography at this level. And our geology students really benefit with their geography and understanding coastal processes and earth hazards in geography. So it mixes very well with them. But we've had students go on from here to do all kinds of degree level approaches, not simply just geology. There are paleontology options, such as at Plymouth and Portsmouth, where we have degrees just for paleontology if you're a mad fossil collector. We have students going on to do geography, physical geography, zoology, oceanography. A couple have gone on to do mining and engineering geology down in Camborne in Cornwall or up in Leeds, where they have particular courses for those. And forensic science, or simply using the geology to get into other science-based university places. So what I would like to do now is get you to meet the students and see how they are going to tell you something about what they intend to do. So I'd like to introduce you to Sophia and William first of all. So if you could join us, guys. Hi, guys. Hi, Sophia. I think we'll start with Sophia. So away you go, Sophia.
The whole course is literally thrilling. Every single unit, it builds up on the knowledge. So everything that you think, oh, I would like to explore it more, will come up later and will be useful later. I currently take geology, classical civilization, and French. which is a weird mix, but they help because I am going up to university to study bioarchaeology. And yeah.
As Sophia said, that geology always builds up on previous knowledge learnt. So it's like each unit is covered various times as each unit involves things from other units. So it's very easy to sort of understand the subject. And when you understand it, it's really easy to gain a better knowledge of everything as each subject sort of builds in, especially chemistry, where you've got all the chemical reactions and things that in geology that forms the rocks and dissolves the rocks as well. The skills games, you've got the practicals, so it sort of links in. If you want to do sciences, you sort of learn how to do practicals and things. Practical skills, sort of recording data and observations, which is very useful, I find.
So now's your chance to drop any questions that you may have into the Dropbox, and I will attempt to answer as they come onto the screen. So thank you for listening, everybody, and I look forward to your questions.
Okay, good evening, everyone. I'm Laura Strong. I'm head of geography here at Hills Road, and I'm just going to read out the questions that you have asked and upvoted during the session, and Dr. Jones and our two students will help to answer them. Okay, so the most popular question this evening was, how many people usually take geology?
Yeah, okay, I'll answer that one, I think. At the moment, we have one class of geologists, so it's normally around about 20 every year. We have 15 in year one, and we had 19 to start with in year two. So yes, compact small groups, so good one-to-one teaching all the way through the year.
And next question, what subjects go well with geology?
I'll take it. Personally, I think they go well with everything because with sciences, they help you add more science or maybe a less claustrophobic science because the workload for biology, chemistry, and physics is massive, while geology is a bit more relaxing compared to in workloads. But it also goes really well with essay subjects or languages, and as a like contrast to the rest of you studying.
Yeah, I mean, it depends on how you want to approach the question, because geology goes well with lots of other subjects. So you can either link it with all the sciences, as Sophia says, such as chemistry, physics, biology, or maths, and you can link it with the social sciences and link it with geography and other subjects. As I said, languages go well with it. It really depends what you want to mix it with, because at Hills you get the opportunity to do so many different subjects. It will in fact fit with a lot of them.
Okay, I've got a couple of questions that are related to this. So one very specific question, which science would you advise to take with geology and geography? In the future, I would like to study volcanoes, tectonic plates, maybe also crystals and rocks too. So what sciences would work well with geology?
If you're looking at volcanology, I think the best option would be either chemistry or physics. Now, if you were actually going to think to do geology or volcanology at one of the main universities, which might be the best two places in Britain, are probably Lancaster and Bristol, they might want you to take actually three of the main sciences. So they might want you to take physics, chemistry, maths with geology, or without geology, in fact. So it's up to you. You need to look at their prospectuses to see what you might want to take. But for that specific question, I would say chemistry or physics would be the best other science to take with those options.
Adding to the uni thing that you said, I've been looking at uni courses as I am applying, and all geology degrees need at least geology as an A level and an extra science, apart from 2 paleontology courses, and
Yeah.
that's it.
Yes, the paleontology courses tend to would rather require biology rather than chemistry or physics.
And another degree related question, is geology a relevant subject for astrophysics?
Yes, it is actually, because as I said, we've had students in the past who go on to do planetary geology. In particular, there are two very good courses at Leeds and in Manchester. And they found it extremely useful because there's a lot of geology involved in understanding the planets.
What is the crossover between geology and geography?
The crossover. Geology is extremely useful for understanding the physical processes in the year one options in geography. So at the moment, geography, and I teach both, does a course called Coasts, and a good understanding of rocks and their resistances to weathering and weathering processes and how they generate landforms such as headlands and bays. It's a fundamental understanding of geology that you require. Now, at year 2 in geography, we teach an option called hazards. And this is fundamentally earthquakes and volcanoes, but it's looking at it from rather a basic component of the geology, but more from a physical, from a human perspective, where we're looking at the impact of major hazards. But understanding why you get the hazard, first of all, is the geological aspect of it, but how humans understand it and how they cope with the hazards and how they can modify hazards is a major element in the year 2 option. So there's a quite considerable crossover both in geography and geology. And the students who take it love it because it works very well together.
Okay, I've got 2 questions related to entry requirements. Do we need a GCSE in geography to take geology?
No. You need, I think, a 6 in maths and a 6 in a science, if I remember correctly.
Correct, yeah.
Yeah. You don't need geography. I mean, obviously it would help for future references because as I've said before, I've never taken geography, so sometimes I have to go and search up things that people that have taken geography know, but you don't really need it.
Okay.
Does the course require strong math skills?
I don't think it really does require major math skills. We can teach all the maths you need to know. How have you found that, William? How have you found the math skills difficult?
Well, I'm not the most gifted in maths, but I think if you can do GCSE maths, you can do geology. Is it the entry requirement has a 6 for maths?
Yeah.
So I presume sort of level 6 sort of work makes sense.
How have you found that, Sophia?
Yeah, no, it's because at the beginning I'd take no math subjects. It was a bit disorienting to find some maths, but once you get reacquainted with doing maths again, then it's not that hard to do the maths.
Okay. Will there be much coursework?
I don't think there's any course.
Apart from the CPACs, there's no coursework.
Yeah, the CPAC assessed exercises and the fieldwork really count as the coursework component in geology. So the 20 sort of set practicals where we sort of assess probably 12 or 13 of them, you have to assess 13. They become the coursework component. So you work throughout the year towards that component.
Next question. How much of the course then is practical work?
A large amount of it is practical work. What do you think, Sophia?
I think we see practical work every lesson. When we are in person, obviously, on site, we always get at least a little box of rocks to identify or maybe use the microscope or the sieving or stuff like that.
Yeah, I mean, the whole point is that I try and give students at least a box of rocks or a box of fossils or some map work to do to sort of make the lessons, well, it's not just exciting because they're actually getting hands-on experience in using these pieces of material to understand how they actually form. So,
plus the classroom is surrounded in rocks, so even if you're not using them, you see them and you can still look at them.
It's a lot of, and of course the two field seasons that we have, unfortunately, they've been cut short this year, but the field work forms a major element of that practical work.
Next question, is there any summer work in advance of year 12? And if so, what is it?
Yeah, there's but it's just not that much. It's just sort of a diagram. It doesn't take more than a couple of hours, I don't think.
Yeah, no, it's I remember when we did it, it was an article and there was a couple of questions about the article and it was a brief summary on what metamorphics, igneous and sedimentary rocks were.
Yeah.
It wasn't bad. Somewhat.
Yeah, it was a couple of articles to go away and read and looking at the processes involved in the rock cycle. And then a lot of students then presented their results as a Prezi presentation, actually. So it got them using skills using Prezi as a presentation method, if I recall.
Yeah, that was a weird website, yeah.
Is geology a hard subject?
Depends if you pay attention, really.
And based on person. Yeah.
Now, I think that if you miss a lesson and then you don't catch up on it, then it becomes really, really hard to understand. But if you keep up with the work, it becomes very not very easy because it is not easy. No A level is easy, but we repeat the work a lot. So if we learn something about sedimentary rocks, we will repeat it a lot until at one point we will know it off by tongue, like off by heart, not by tongue, sorry. So it becomes easier if you keep up with the work.
Yeah, I mean, the course at the start is quite heavy going because it's a brand new vocabulary. It's a lot of new rocks, minerals, and things to try and understand from the start. But once you get over that first difficulty, I think it then becomes a lot easier. And as Sophia and Will have said, what we do is consolidate a lot through the year. A lot of the year 2 options build on an understanding from the year 1. So there's a lot of revision component built into them as a result of the way it was designed, so that you tend to do things at a higher level in year 2, but you've already seen those things in year 1. So it sort of builds on it.
Okay. The next question is general. I'm happy to answer this one. A little off topic, but are you able to take 4 A levels, or are you restricted to 3 here at Hills Road? So it is possible to take 4 A levels, but it's really considered on a case-by-case basis. So if you have a very strong GCSE profile, then you may well be able to take on 4 A levels. So if you feel you're a candidate with potentially 7, 8 CE, apply and see if you're accepted to take 4. Okay, next question. Would geography, geology, chemistry, and biology be too ambitious to consider studying?
Yeah, so there is a very large amount of work in biology and chemistry. But a lot of students do go down that line, and what they tend to do, they try it out, and if it does get too much, then they tend to drop one of the subjects. So they give it a go and see how it goes on. We have a fair amount of students doing 4 subjects at the moment in geology, and they seem to be coping okay, but it depends what those 4 subjects are. But that would be a very heavy load, I would think.
Yeah, that would be because chemistry, biology, and physics have a lot of work.
Yeah, biology especially, it's got a lot of theory. So you've got to learn a lot of things for it.
Okay, well, that brings us to the end of the questions that you have submitted for this evening. I'd like to thank both of our student helpers for joining us and for sharing their experiences of the course, and also to Dr. Jones for neatly summarizing what your experience at Hills Road could look like if you choose to take geology, and we very much hope that you do. Thank you for joining us this evening.
Yeah, thank you, Will. Thank you, Sophia.
Thanks.